Okay, good morning, fifth graders. We have a 1 hour delay, so I have time to actually do these problems here. And I'm not sure how I'm going to do it. I think I'll pull 9 sticks and have you guys come up and do them on the screen, and we'll see how they come out. Maybe earn some points that way. But anyways, I'm just going to go through these really quick, and maybe I'll pause at each one when you guys are here in class and see if the answers that you guys come up with are correct or not. So let's do these here. So first thing we have to do is find a common denominator. I'm looking at number 1 here, 2 and 6. 6 is a good choice because 6 will go into 6 evenly, and 2 will go into 6 evenly. So this is the question that I asked myself. How many times does 2 fit into 6? It goes 3 times, and 3 times 1 is 3. 6 goes into 6 once, and 1 times 2 is 2. Now, some of you, yesterday I noticed you were asking yourself how many times, for example, this one right here, how many times 2 goes into 6? That's not what you do. You want to figure out how many times the denominator, one denominator goes into the other. You're looking at the bottom. So now what do? We just simply add the numerators. 3 and 2 is 5, and so the answer to number 1 is 5/6. Let's look at number 2. What's the common denominator? A number that both 8 will go into and 4 will go into. Well, I think 8's a pretty obvious choice, and so I'm going to put down 8. And again, you're not then going to ask yourself, looking at the numerators, how much or how many times they go into 8. You look at the denominators, one denominator going into the other. Well, how many times does 8 go into 8? Once. And 1 times 3, we're multiplying it to the denominator, or the numerator, is 3. How many times does 4 go into 8? Twice. And what's 2 times 3? 6. Now we just simply add the numerators. What's 6 plus 3? 9. Now we have something that I talked about very briefly at the end of the day yesterday. We have an improper fraction, and that's when the denominator, that's the number on the bottom, is smaller than the numerator, that's the number on the top. And I'm not going to mark that wrong for today, but in the future what you would do is then say to yourself, well, how many times does 8 fit into 9? Or if I subtracted, you look at it this way. If I subtracted 8 from 9, 8 would fit into 9 once. And then 8 from 9, there's 1 left over. And then the denominator stays the same. So if I wrote 9/8 equals 1 1/8, that's correct. That's accurate. Those are the same thing. And this is called, I heard somebody say it the other day, this is called a mixed fraction, when you have a whole number with a fraction. And when you have a fraction where the numerator, that's the number on top, is larger than the denominator, that's an improper fraction. So let's look at this next one here. In the first 2 cases, we used one of the denominators. And that's often the case. But in this one, we can't. So we have to think of a number that both 2 and 3 will fit into evenly. And that number would be 6. So 3 goes into 6 twice. 2 times 2 is 4. 2 goes into 6 3 times. And 3 times 1 is 3. So now what do? We add up the numerators, the numbers that are on top. So 3 plus 4 is 7 over 6. So what do we have here? We have another improper fraction where the number on top is larger than the number on the bottom. So how many times does 6 go into 7? It goes in once. And if I subtracted 6 from 7, there'd be 1 left over. And the denominator, as I've said before, stays the same. So 7 over 6, which is an improper fraction, is the same as 1 1/6, which is called a mixed fraction. Okay? Next one, We have 1/2 and 5/8. Well, 8 I think is a good choice. How many times does 8 go into 8? Once. 1 times 5 is 5. How many times does 2 go into 8? 4 times. And 4 times 1 is 4. Now we add them up. 5 and 4 is 9/8. And once again, what do we have? We have a improper fraction, where the denominator is smaller than the numerator, the number on top. And so what would I do? How many times does 8 fit into 9? Once. What's left over? If I subtracted 8 from 9, 1's left over, and the denominator stays the same. All right, number 5. 1/2 and 3/6. Well, let me point out something to you. Well, let me go ahead and just do this one. So what's the common denominator we could use? We could use 6. I think that's an obvious choice. 6 goes into 6 once. 1 times 3 is 3. 2 goes into 6 3 times. And 3 times 1 is 3. Now we add up the numerators. That's the two numbers on the top. The denominator is going to stay the same. 3 plus 3 is 6. So we have 6 over 6. Well, what does 6 over 6 equal? 1. Any number over itself is 1. If I had 17 over 17, that would be 1. If I had 20 over 20, that would be 1. If I had 0.3 over 0.3, that would be 1. Some of you may have recognized, I'm looking at number 5 here for a moment, that 3 over 6 is the same as 1/2. Just like 5 over 10 is the same as 1/2. And so you could have asked yourself, well, what's 1/2 plus 1/2? Well, a half plus a half is 1. So that might have saved you some time on that one. Okay, number 6. What's the common denominator we could use? Well, in this case, it happens to be 14. 7 goes into 14 twice, and 2 times 5 is 10. 14 goes into 14 once, and 1 times 5 is 5. So what do we have here? Add the numerators up. 10 and 5 is 15 over 14. And once again, we have an improper fraction. How many times does 14 fit into 15? It goes in once. There's 1 left over, and the denominator stays the same. And in all these, what's been left over has been 1, and that's not always the case. It just happens to be with these problems that I made up off the top of my head. All right, number 7. We have 1/2 and 4/5. So what's a common denominator we could use that both of them would go into? Well, it'd be 10. 5 goes into 10 twice, and 2 times 4 is 8. 2 goes into 10 5 times, and 1 times 5 is 5. Now we add them up. 8 and 5, we're adding up the numerators, the numbers on top. It's going to be 13 over 10. Well, in this case, we have an improper fraction, but it's not going to look quite like the ones we've had. So 10 goes into 13 once. What's left over? 3. If we subtracted 10 from 13, 3 left over, tenths. So 13 over 10 is equal to, or is the same thing as 1 and 3/10. Did I start the recording on this? Yes, I did. Good. I was thinking I forgot for a moment. All right, what's the common denominator here for number 8? We're almost done. 12. 12 goes into 12 once, and 1 times 1 is 1. 4 goes into 12. Pause that. 4 goes into 12 3 times, and 3 times 3 is 9. 1 plus 9 is 10 twelfths. Now, that's not an improper fraction. That one's fine. But we can reduce that. And when I say reduce, you want to look for a number that will go into 10 and 12 evenly. Well, 10 can be divided by 2, and so can 12. So how many times does 2 go into 10? 5 times. How many times does 2 go into 12? 6 times. So 10 twelfths can be reduced to 5 sixths. All right. I would have accepted 10 twelfths. There's nothing wrong with that. But in time here, you guys will reduce all the fractions that can be reduced. All right. Last one, number 9. What's the common denominator? I think I would use 20. It's kind of obvious. 20 goes into 20 once. 1 times 7 is 7. 10 goes into 20 twice. 2 times 3 is 6. What's 7 plus 6? That's 13 over 20. Can't reduce that. There is not a number that goes into 13 and 20. Okay. Done recording that. Did it in less than 11 minutes and 5 seconds. If I can turn it off here.